In this video, let us continue to solve more problems based on sets. Alright, so here we've got a problem which reads like this. It says, let set A be equal to A, B, C, D, and let set B equal to A, B, C, and let set C equal to B, D. Find all sets X such that X is a subset of B and X is a subset of C. And in another case, X should be a subset of A and X not being a subset of B. So X should be a subset of A, at the same time it shouldn't be a subset of B. So let's come to the first part of the problem here. X should be subset of B as well as X should be a subset of C. Okay. So when you consider the sets B and C, the common terms in both of them are B. Alright. And empty set is present in all the sets. So therefore, we need to find all sets X. So X will be equal to the empty set phi and only B. So when X equals empty set comma B, then X is a subset of B and X is a subset of C. Alright, so this is how you solve this problem. So in that case, it also means that X belongs to the set B as well as the set C. So that's the first problem. This is a very simple and a straightforward concept, not much to break your head about and stuff. So now let's go to the next one, which is X is a subset of A but not a subset of B. Alright, now coming to the second one, X should be a subset of A, at the same time it shouldn't be a subset of B. So whatever is common between A and B should be taken out, and whatever is uncommon only should be taken in. So in that case, this is the second problem. So X will be equal to definitely D. D is not there in B. So X will be a subset of A but not a subset of B. At the same time, it can be A, B, D, right? Because as a set, this does not belong to B. Although A and B belong to B, the whole thing doesn't belong to B. So therefore, in this case, X is a subset of A but not a subset of B because there is one extra term D here. And next can be B, C, D. At the same time, same concept applies. X is a subset of A but not of B because there is D. And next will be A, C, D. Just by keeping one alphabet, you can create a lot of elements, or all sets, in fact, all sets such that X is a subset of A but not a subset of B. So A, C, D is one, and another one can be A, D, and another one can be B, D, and it can be C, D, and finally we can have all the terms A, B, C, D. So if you notice all these sets carefully, which is X equal to all these sets, all these sets are such that X is a subset of A but not of B. That is why we haven't even included the phi, that is the empty set, because empty set is both present in A and B. So if you write empty set, then that set becomes such that X is a subset of A as well as B. But it's clearly given in the question that X should be a subset of A but not a subset of B. That's why we have to really not write the common terms between A and B and write only the uncommon terms or uncommon sets. That's exactly what we've done here. So in that case, then X is a subset of A and it is not a subset of B. So the condition is satisfied and hence the problem is solved. So that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on sets.